When we try to determine these limits, what are we really looking for? Why am I determining these limits?
We're trying to find the sign.
Careful, we're talking about the function. For the function, we never look for the sign. Very good point. We look for the sign only for f prime and f double prime. We never look for the sign. You mean here, in a way. I think I understand what you're saying here. The sign, if it goes to infinity, negative infinity, and okay. But yes, if that's what you're saying, good. But what about here? If I want to determine this limit, one of these two limits, what am I really looking for? And here's my hint.
The horizontal asymptote.
Exactly. If these two are numbers, then there is a horizontal asymptote. What if they are infinities? Is there a horizontal asymptote if these two are infinities? If I get infinity here and negative infinity here?
No.
No. So it has to be a number. Awesome. That's what we are doing now. So limit as x approaches negative infinity from 1 over x plus 5. And then limit as x approaches infinity from 1 over x plus 5. And remember, we have these category here that we wrote together, in case you forget. So what is the answer? One divided by huge. What would that be?
0.
Exactly. And we know that because the degree of the denominator is higher than the degree of the numerator. What does that mean? What is the horizontal asymptote? Y equals
0.
That's it. So I write myself a note. Don't forget, we have to graph y equals 0 as the horizontal asymptote. Awesome. So now let's determine these two limits. The limit from the left of negative 5 of 1 over x plus 5, and the limit negative 5 from the right. Now this is a totally different story, because this is 1 and this is 0. This is 1 and this is 0. And we remember there are three options for 1 over 0. So 1 over 0 has three options: infinity, negative infinity, or DNE. What is this one? What is this one? Remember here, negative 5 from the left, so you will be using negative 5.1. Here, negative 5 from the right, you will be using negative 4.9.
The top will be negative and the bottom will be positive.
Very good. So I go back quickly so I don't forget. Right back to my table. Now I need these two. Limit from the left. So obviously this means that x equals negative 5, we already wrote it, is a vertical asymptote. Okay, now we want limit as x approaches 3 from the left, and limit as x approaches 3 from the right. This is not this, and this is not this. This is the easiest of all of them. What is the answer? Anyone?
Positive.
Yes, they're both positive. But what?
1/8.
Yes, awesome. All we have to do is plug in 3. 3 plus 5 is 8, 1 over 8. So can anyone now give us the hole or the open point?
318.
Yes, brilliant. 318. Quickly back to the table. Quickly back to the table. Now I finally finished with this. I found there is no y-intercept because the numerator cannot be 0. So, no, I meant no x-intercept because the numerator cannot be 0. So I have limits at infinity. I have limits left and right of the vertical asymptote and the whole. Of course, both of them have to be the same. It's a whole. By whole, I mean one branch is not here, another one here. No, it's a whole. So left and right have to be the same. And now I have everything here. I'm going to find the first derivative, critical numbers sign, second derivative when it's 0 or undefined, and sign. And I'm done, and I'm ready to graph. Okay, so first derivative. I'm going to use 1 over x plus 5 as x plus 5 to which power?
-1.
Perfect, awesome. Can anyone give us the first derivative?
Negative x plus 5. -2.
Times the inner function prime, which is?
1.
Excellent. So this will look like this. Now keep it from this point and just let's find the second derivative.
Two
Yes?
times x plus 5, -3.
Times the inner function prime, but there is no need because the inner function prime is?
1.
Excellent. Awesome. So 2 over x plus 5 to the third. Good. So let's look at this. 0 or undefined? You can say, yes, it's undefined at -5. There is no need because the function is undefined. So that will not be a critical number. Can this be 0? Remember what we said. A divided by b is 0 only when? Very good. Can the top be 0?
No.
No. So there are no critical numbers. Fine. Can anyone give us the sign of this expression? Because I have to put it in. Now I have to punch in the sign here.
Negative.
Always negative. Because this is always positive. This is always positive. This is always positive. But it has a minus in front. What does that say about the function? What does this sign say about the function?
It's decreasing.
Always decreasing. Awesome. Awesome. Good. Now I need to make sure that that's the case. From 0 to -infinity, what does the function do?
It's decreasing.
Awesome. From infinity to 1 over 5, which is 0.2, and this is 0.125, 0.2, 0.1, and then to 0. What does the function do? Yes, and that's clear. Awesome. So far, so good. No max min, because the first derivative doesn't change sign. That's why it's always decreasing. It cannot have a max min. If it's always decreasing, it never turns. Okay, now let's analyze the second derivative. Can the second derivative, which is 2 over x plus 5 squared, cube, sorry. Can this be 0?
No.
No. Can this be undefined? Yes, at -5. But so is the function. So nobody cares. That's not a critical number. Okay, now we have to establish the sign. So, to the left of -5, pick a number, plug it in, and just give me the sign. Like, for example, -10. -10 plus 5, what type of number will this be?
-5.
Yes, to the third power. Now, a negative number, no. So what will be the sign of the second derivative for anything to the left of -5?
Would be negative.
Perfect. Which means it does not hold water. Now let's pick a number to the right of -5. Let's say 10. You can pick a 0. That's the easiest. I picked 0. That's gone. What is the sign of this expression?
That would be positive.
Exactly. Thank you. Always positive in the rest. Which means it holds water. It holds water. Done. I don't care about any of this. This is gibberish now. Useless for graphing. I already used it. It's in the table. I don't care to see anything else. Anything else will be a simple distraction. It will not help. The table tells me everything I need. When we graph functions with asymptotes, we have to graph the asymptotes first. So there is a horizontal asymptote at 0, but there is no need. I already have it. I'm just going to emphasize it by writing it here, so I know I didn't forget. It has a vertical asymptote at -5. 1, 2, 3, 4, 5, and here it is. So this is my x equals -5. That's done. I will have to plot this point, which is an open point, and of course this one. Hard to plot point 2. I'm going to say it's here, 0, 0.2. Hard, even harder to plot 3, 1.25. 1, 2, 3. I'm going to say it's here. But this, just make sure that I'm going to re-emphasize it as an open point. So now I read my table. Ready? From 0, dropping to -infinity, decreasing, of course, dropping, and opening downward. Fine. From the horizontal asymptote, decreasing, dropping to -infinity on the left-hand side of the vertical asymptote, opening downward. This is done. I'm here now. It's coming from +infinity, dropping to and crossing the y-axis, further dropping to the hole, further dropping to the horizontal asymptote, always opening up. Again, from +infinity, crossing the y-axis, continue to drop to this hole or open point in the graph, and then continues dropping, still opening up to the horizontal asymptote. And this is the graph of x minus 3 over x squared plus 2x minus 15. Now I wanted to show, but forgive me, I'm not ready because I did not, I had all this open up for you, but because I rebooted my system. So now if you want to use the graphing calculator, you have to know what you're doing, please, because the graphing calculator will not present the open point. You will not see it. So please don't rely on the calculator. I'm not saying the calculator is wrong. I'm saying you have to know what you're doing. Otherwise, the calculator is not helping. So x squared plus 2x and minus 15. And close. Yes, I will also put the 0 because that's the horizontal asymptote. I know what I'm looking for. So I will adjust the viewing window accordingly. So I know there is a vertical asymptote at -5. -7 is okay. Maybe I want to go to -10. X maximum, there is no point in going above 5. There is no action after 3 anyway. 7 is fine anyway. Now, Y minimum, I don't care for more than -4. Y maximum, I don't really care more than 4. The height is at 0.2 or 0.125. So why would I go too far? Okay, with a scale of 1. I know exactly what I'm looking for. I press graph. Aha. So here's the horizontal asymptote. The vertical asymptote is missing, but we know it's at -5. And if you really, really want to see what's happening here, you can. But also remember, if I plug in the function, let's say I want to plug in -5, what will a function say? What will the calculator do? When I plug in -5, what will it say to me? It will say, you lost your mind. And it has to. Why? Why would it say that I lost my mind?
Because there's a vertical asymptote.
Because it's undefined and it's a
value.
vertical asymptote. What if I plug in now 3? What will the calculator say to me?
Same thing.
Exactly. It has to say the same thing. Although when you look at the graph, you say, oh, how come? So now let me show you. I'm going to change the viewing window to 2 to 4 with a scale of 1, from -1 to 1 with a scale of 1. And let's take a look. Oh, look at that. You see here? A little pixel is missing. So when x is 3, the height is 0.125, and it's a little hole in there. As you see, it's not a vertical asymptote. Okay? So be aware of that. Okay, I think that's more than we really needed. I wanted to look at word problem here, or we can move on to other word problems moving forward. So because I rebooted my system and I wanted you to not to wait, I don't have the book open in the background yet.